Welcome to Global Tuition Center. It's another day. It's your teacher, Mr. Lu. As for today, we have an interesting topic which has to do with waves in physics, also in science. Others, they know it as science, but it's called physics. So the question, it comes from 2025, paper 1, GCE, which is question B5. So the question reads, the figure below shows a wave with a frequency of 40 Hz. So you have been given the frequency of 40 Hz. Then, now when you see this diagram, here there's displacement. Then there's a distance from here up to there. Now, by definition, the distance from here up to there, it's called a wavelength. Because a wavelength is the distance at which the wave repeats itself. So you can see where the wave started. The wave started from this point. Since it started from this point, then you can see up to here, then it had to continue the same thing, meaning there's a repetition from here up to there. Now the distance, the minimum distance at which the wave repeats itself, it's called a wavelength. So therefore, we can conclude saying the distance from here up to there, it's called what? Wavelength. Then we can proceed. Now the first question there, we're told to calculate or to define rather what we call amplitude. Now what is our amplitude? Our amplitude is the distance from here up to there. The distance from here up to there, remember this is the resting position. Now the distance from here up to there is the amplitude. Now what is the definition? So here you can see there is displacement. So for amplitude, I'll simply say is the maximum. So maximum displacement of the particle, maximum displacement of the particle from its resting position. So is the maximum displacement of the particle from its resting position. Now the second question here, we're told calculate the speed of the wave. Now for us to calculate the speed of the wave, what we're supposed to do now, by definition, when you are taught to define the speed of the wave, you need to know that is the distance covered by the wave per second. Now in other ways, the distance from here up to there, we're taught to find the speed of that particular distance. So I'll say distance is represented by V, which is equal to the frequency there times the wavelength. So don't forget that this is the symbol for wavelength. Then I'll proceed there. I'll say speed equals the frequency. You can see here there's 40 Hz. So I'll just say 40 Hz there times the wavelength is the distance from here up to there, which is 1.5. So when you calculate there, you end up with 60 meters per second. So meters per second, the units of speed. Then we go to the next question, which has to do with period, which is our question C. Now question C, we are taught to calculate period. Now by definition, the term period, it simply means the time it takes to make one wavelength. Now we can go back to the diagram. So now we know that the distance from here up to there, it's called a wavelength. Now the question is, how long does it take for it to be completed from this point to that point? Because we know this is a wavelength. So now the time it takes for this distance to be completed, it's called a period of a wave. So the time it takes to make that wavelength. So we know that period is represented by T. Then there are two formulas depending with what you have been given. So now I would have used this formula, which is T over N. Now in this case, we have not been given time, so we can't use this formula. So I'll use this formula, which is T equals 1 over F. Because we know that period is inversely proportional to frequency. So in other words, what I mean when I say inversely proportional, I mean when you increase period, it simply means you are reducing what? Frequency. So in this case, I'll say period equals, there's a 1 there over the frequency on our question, it was 40. So when you divide there, it will be 0.025 seconds. So these are seconds. So this is our answer. Your follow to this group will take us far. Thank you very much.